In this question here, we have a particle A moving at the speed of 20 meters per second to collide with a stationary particle B. Now, after collision, these two objects are going to move in opposite direction as shown there. One will move upward with a velocity v, and the other one will move at 7 meters per second in this direction. And we are supposed to find the value of v and find the angle beta. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload another tutorial like this, you'll be notified. Now, how are we going to work out this particular question? Of course, our target is find theta and v, and we're going to use the principle of conservation of momentum. Momentum before collision is equals to momentum after collision. Now, we are going to consider horizontal component of momentum and the vertical component of momentum. So let's look at horizontal momentum. Horizontal momentum. And we are going to look at that before collision. And you can see now horizontal momentum before collision. We are talking of this object. This is the only object that is moving because is moving at 20 meters per second, but this object is at rest. So which will mean that momentum before collision is going to be 20 times 10 times 20. That is going to be 200 kg meter per second. Then after working on that, we are going to work out the momentum of this object in that direction, and also we shall work out the momentum of this object in this particular direction. So momentum of A, because after collision A moved in that particular direction, so the momentum of A is going to be equal to the mass of A, which is 10 kg, times the velocity at which it will be moving. So this is going to be 10 v. But what will be the horizontal component of this momentum of 10 v? The horizontal component in that case is going to be equal to 10 v cos of that angle that we are talking about at this point. So this is the horizontal component of object A after collision. Then also we are going to work out the horizontal component. First, we need to work out the component of B, or the momentum of B in this particular direction. So take note of this as the horizontal component of A. Momentum of B now is going to be equals to what? Because it moved at a speed of 7 meters per second here, so we are going to say its momentum is going to be 8, because this mass has a total mass of 8 kg and it moved at a speed of 7. That is times 7, and that translates to what? That translates to 56 kilogram meter per second. So the momentum of this object in this direction is 56, but we are now interested with its horizontal component. The horizontal component of B is going to be 56 cos of which angle? Cos of 34 degrees. And that becomes horizontal component of B. Horizontal component of B. Now, once we have this, we are going to say now momentum before collision is equal to momentum after collision in the horizontal direction, which is going to be, the first one is this one, which is 200. So we're going to say 200 plus 0. Before this collided with this was moving at which speed? 0. It wasn't moving. So it was the momentum in the horizontal direction before collision was 0. And after collision, we got that the momentum of A in the horizontal direction is this value that we got here. So we are going to say this is going to be 10V cos theta, right? Cos theta. Cos theta. And then plus the momentum of B in the horizontal direction, we got it here, which is going to be 56 cos 34. So you can see we end up having 200 is equals to 10V cos theta plus 56. This is going to translate to what? 56 cos 34. 56 cos 34. That translates to 46.4. 46.4. And then we can say now 10V is equal to 200 minus 46.4. Then we can divide by 10. We can divide by 10 at that point. V is going to be translating to, this is going to be 200 minus 46.4 divide by 10, and that becomes 15.36. So we can be able to take this on the other side, and we can have 10V cos theta is equal to 200 minus 46.4, and then we can divide by 10, divide by 10. This and this we cancel out. V cos theta is going to be equivalent to what? V cos theta is going to be equivalent to 200 minus 46.4 divided by 2. 200, we have 200. We are going to put this in a calculator, and this is going to be 200 minus 46.4, then divide by 10, and our answer translates to 15.36. This one becomes, our answer here is 15.36. And we are going to call this as our equation number 1. The next thing that we are going to consider, as much as this object is moving, having the horizontal component, horizontal, it will be moving horizontal, is having the horizontal component of momentum. It will be also having vertical component of momentum, and this one will also be having a vertical component, but in the opposite direction. But this object, when it was moving before collision, this was moving horizontally on the x-axis. So it was neither moving up nor down. So the vertical component of this momentum would be 0. It wasn't moving up, it wasn't moving down, it was only moving in the x-axis. So it's going to have only horizontal momentum. So before collision, object A and B, both of them were having 0 momentum in the vertical direction. So we can also consider vertical momentum, because this object was only moving the x-axis, x direction. So we are going to say momentum in the vertical direction before collision is 0. is equals to, this one will be having momentum in the y direction. But what is the momentum of this object in this direction? Is equivalent to 10v, but this is going to be actually is going to be 10v sine theta, because it's moving in the y direction. Let me just write it here properly. This is going to be 10v sine theta. To be moving up, the momentum in the y direction will be 10v sine theta. 10v sine theta plus this one will be having a vertical component, but that vertical component will be acting down, so it's going to be 56. Because momentum in this direction is 56, then since we are finding the vertical component to be 56 sine 34. But now when we are adding here, this momentum is up, this one is down, we are going to put a negative sign for this one because it's acting in the downward direction. So it's going to be 56 sine 34. So which will mean that from this particular equation, we are going to have 56 sine 34 is equivalent to 10v sine theta. We can be able to simplify this equation that we have at this point. 56 sine 34, 56 sine 34, which is going to be equivalent to 31. I'm getting 31.31 here. 31.31 is equals to 10v sine theta. So we can divide by 10, we can divide by 10 at this point, and we shall end up having v is equals to no, not v, but we are going to have v sine theta. V sine theta is equals to 3.131 at that point. And now we can say this is our equation number 2. So we had gotten equation number 1, and we have our beautiful equation number 2, and which will mean that solving equation 1 and 2, solving equation 1 and equation 2, we can see now we have this. We can divide equation 2 by equation 1, and this is going to be, let's divide equation 2 by equation 1. Equation 2 is written as v. Equation 2 is written as v sine theta is equals to 3.131, and equation 2 we divide it, which is v cos theta, and that cos theta is equals to 15.36, right? So you can see v and v is going to cancel out. We are going to remain with sine theta over cos theta is equals to what? If we divide the two values, which is 3.131 divided by 15.36, that translates to 0.2038. 0.2038. Now sine theta over cos theta is actually tan theta, which is going to be equal to 0.2038. Then to get theta, it will be tan inverse of 0.2038, and working it out, finding the tan inverse of that is 11.5 degrees. We are getting 11.5 degrees. Now we have gotten the value of theta for this question, and then the next business we have is to work out the value of v. From equation 1, from equation 1, we can see that from equation 1, we can see that we have V cos theta is equals to 15.36, and our theta we have gotten to be this value that we have here. So meaning we are going to say V cos 11.5 is equals to 15.36. We can say V is 15.36 divided by cos 11.5. And if we work it out, let's see the value we are getting. This is going to be 15.36 divided by cos 11.5. I'm getting 15.67 as the final answer. My answer here is 15.67, and that is going to be meters per second. I would like to check, just for curiosity, and check whether that is true. If I used equation 2, will I get the same answer? If I used equation 2, let me check whether that is true. If I used equation 2, this will have been V sine theta, and our theta, we got it at this point here. This is our theta, which is 11.5, is equals to 3.131. So V is going to be equivalent to what? V is going to be equivalent to 3.131 divided by sine 11.5. And let me just put it in a calculator and check whether I'm getting the same answer. Sine of 11.5, I'm getting 15.7, which is actually the same thing. 15.7, 15. I'm also getting 15.7. So we can see now, after using the principle of conservation of momentum, we have gotten this angle is 11.5, and the speed at which this object moved in that direction is 15.7 meter per second. That is our value of V. If you have gotten value from this video, consider subscribing so that anytime we are going to upload another tutorial, you'll be notified. See you in the next video.